Okay, so my name is Ana Beatriz, and we chose three scientists that were really important during the beginning of life. And the first one is Francesco Redi. He became famous for his experiments that proved that spontaneous generation was not real. Um, he demonstrated that the presence of maggots in meat does not result from spontaneous generation, but from eggs laid on meat by flies. And the other one that we chose was Alexander Oparin. He had a theory of the origin of we chose was Alexander Oparin, and he got famous for a theory called primordial soup, in which the theory stated that life began in a pot of ocean as a combination of chemicals from the atmosphere then formed energy to make amino acids. Alexander added that he had building blocks of protein, and like that began the living species on Earth. It was called the theory of the evolution of life from carbon-based molecules. He also thought that life formed through energy, such as sun, lighting, and etc. And the Earth's heat had chemical reactions from tiny molecular substance. Then it rained, and that rain formed the primordial soup.
So, Louis Pasteur designed an experiment to test whether sterile nutrients broth could spontaneously generate microbial life. Uh, to do this, he set up experiments in both Pasteur added nutrient broth in flasks, bent the neck of the flask into S shapes, and then boiled the broth to kill any existing microbes.
Earth is 4.6 billion years old. Earth back then was just a ball of rock surrounded by an atmosphere. Early Earth barely had any living organisms due to its lack of oxygen, so there weren't any plants nor animals, and very
We like water. Let's get it.
What Bia said was true. There were very little organisms due to the lack of oxygen, but there were still chemistry in early Earth. There were still chemicals. Those chemicals were water vapor, nitrogen, carbon dioxide, hydrogen, methane, and ammonia. Those were all the chemicals included in early Earth. And those chemicals, they were placed in the soup or the center of the early Earth's atmosphere. And there, like me and B explained earlier, there were numerous theories about early Earth testing life. We got Reddy's experiment, for example, Pasteur's. There's like millions of experiments testing early Earth, like life before, like what generates life. So, according to scientists, there were four requirements, uh, and these requirements were simple organic molecules, four requirements for life. Those requirements were simple organic molecules, a way to synthesize proteins from amino acids, coding system for replicating protein, and the formation of membrane. There was also four concepts that were all life contain DNA, and
So now we're going to talk about evolution. It all started in 1835 with Charles Darwin. One day, Darwin sailed from his home in England to the Galapagos Islands. The Galapagos Islands are a bunch of islands outside of Ecuador. So when he was in the Galapagos Island, he observed that there were finches, and that all these finches kind of looked alike, but they weren't the same. So he started collecting the finches, and he realized that in each island, the finches had different beaks. Some beaks were sharper, others were smaller, others were bigger. In each one, some beaks were to fruits, and others were to scavenge for worms. So Charles Darwin created the theory that at some point those birds flew off. One species of bird flew off from the mainland and reached the Galapagos Islands. And as the years went by, they evolved into their children evolved to have these beaks for better survival. Another example would be the whales. So, an interesting fact about whales is the fact that they, in their flippers, they actually have for all hand bones. They have the hand and they have the finger bones. And they also have what seems to be hip joints. So what scientists pretty much concluded is that at some point they had an ancestor that was able to walk on land. And that ancestor was called the Amblophosaurus whale. This whale was said to be able to walk on land first because it had fully formed legs and strong hip bones that gave it the capacity to walk on land. So another thing would be natural selection. So in England, there were these trees that were covered with this kind of white sap, and there were moths in the forest. And most of the moths were white because they were able to blend in to the white trees and predators wouldn't find them. But then there were the black moths, which didn't blend in as well, so pretty much they were dead meat. So when the Industrial Revolution started, the smoke caused all the trees to go black. And all the black moths were able to survive. But then all the white moths started to pretty much die out. And as they could see, what they saw was that there was a huge increase in the number of black moths and a huge decrease in the number of white moths. And this was a very important concept for natural, and this was a very important example for natural selection, that the organism that has the best tools for survival lives on, and it passes it on to its children. And their children will at some point probably evolve to gain these tools or make it better. So that's it. Thank you.